Good afternoon. My name is Wanjohi Ian Kinyo. I'm presenting a project on using random forest algorithm for blood stock optimization in Banadir Blood Bank. So this is my registration number from BIT. My supervisor is Dr. Dennis Kaburu. So in chapter 4, we are going to look at system implementation and testing. So this chapter presents the implementation process of the proposed blood bank. It shows the environment in which the system was developed, the tools and technologies that were used, the testing strategies, and also the conclusions drawn from the project and offer recommendation for future enhancements. So for the environment and tools, the front-end development was built using HTML5, CSS3, JavaScript with Bootstrap for a responsive design. It ensured a user-friendly interface for medical staff and donors. For the backend, it was developed using Django framework, using the MVT architecture. For the middle layer, it was handled by Django views and models for form submissions, validation, and communication between the front end and database. For the database, SQLite was used. For the machine learning model integration, random forest classifier was used using historical blood request and the stock data, and the deployment was done via Flask API for real-time stock predictions. So I will showcase my system. So this basically the landing page or the home page. So we log in as an administrator. So basically the administrator, this is the landing page, so they can be able to see the stock that is available for the different blood types. For the A positive, you can be able to see. For the B positive, you can be able to see. And this is the prediction page. So basically in the prediction page, the administrator have a graph to show the blood demand. And from this, you can be able to see B positive is the one that has the highest demand. So here for the stock prediction, it shows the total requested for the whole data set of the previous year, like 49,744, and the current stock is 5,218. So the minimum stock that should be maintained in the stock is 6,218. So basically, to be able to reach the threshold of this minimum stock, you need to top up a blood stock of 1,000. So this is where the machine learning predictions comes in, which will be illustrated in a few. So let me illustrate it. Let me log out and log in as a patient. So for the patient, you can be able to see, once I click here, make request, say it's Ian Kinyo. The date of birth calculates automatically once you select your date of birth. The reason, let's just say urgency. For the blood group, we have O negative. We have units in milliliters. We have 2,000. Then you request. So it comes here to the request history. It's the last one. So you can see here it's pending. Once I log out as the admin will be able to see that O negative, the total requested for the last 1 year, including the one that we have requested right now, is 59,000, and the current stock is this one. So the minimum stock that should be maintained is this one. So now, because that the blood bank has met this minimum, so the required stock is 0. So the admin will be able to also view the donor's details from here. He will also be able to view the patient details from here, the donation details from here, and also the units added from the donations that have been made. They can also be able to print from here. The admin will be able to also approve or reject different requests. They will be able to view the history. This is combined together with the data set so that it can be able to gain more insights to understand the patterns. They can be able to print the blood request history from here. and also make maybe a PDF from that. The admin can be able also to update for stock. So let's say for negative, they can update for like 3,000 and update. So that will be visible here for negative. So meaning still the minimum stock that should be maintained is this one, and the current stock is this one. So no required stock that will require to be topped up. So as the donor can be able to log in from here. So basically, sorry, naweza pause. So let's say the donor that we are requesting this blood type O negative, and the minimum stock is this one. Mark these values 59,000, and the current stock is 10,000. So I will log in also as the donor. We will log in first as the patient. Now as the donor, let me log in. So the donor can be able to donate different blood types. Once accepted, they will be added to the stock available. They can be able also to view the donation history. The donor can also be able to make blood requests. Let's say this is the name, the date birth, and the reason urgency. We said you note down the values for O negative, and the units in millimeter are 3. Let's request like 6,000. Once I request, it comes here. So you can see it calculates the age. Once I log out and log in again as the administrator, you will be able to see here the total requested is now 65,000. Once, let's say, I approve that request, let me show you. Once I approve this request, once I approve you and come back here to predictions, you can be able to see the total requested is still that one. The current stock goes down from 10,000 to 4,000. So, and the minimum stock level to be maintained now has increased based on the predictions that have been made, and the required stock that needs to be restocked is this one now. You can see now it has been identified. So now moving on to the testing. So in our testing process, we focused on ensuring the system met user requirements at every stage of the development. Each test was compared against the expected outcome. So we start off with the unit testing for verifying forms, views, and models. So in the unit testing, it tested individual components such as the forms, which validated form input for registration, views functions, which ensured views like make request view, donor dashboard view, and admin dashboard view worked independently. For functional testing, it confirmed all user roles could perform the core tasks as intended. So it confirms that donors can register, they can log in, they can donate blood, and they can view history. The patients can sign up and request for blood. For the integration testing, it tested how components interact, including the form submission triggering the correct view and updating the database, blood request approval automatically adjusting stock levels, Django system communication with the Flask machine learning API for predictions. For the user acceptance testing, real users such as the admin who are my clients validated that the system was user-friendly and met the expectation. For the black box testing, it tested that from the user's perspective that correct system behavior for different user roles, no exposure to internal logic, but correct outputs were received from input. White box testing, it reviewed backend logic, control flow, and exception handling, and logic flow in views and models, if else branches, loops, and exception handling, and the code performed as expected. As you can see here, these are the different views and forms that I'm talking about. They are well shown and well tested. So for stress testing, the developer used Locust, which is an open source load testing tool that simulates multiple users to test the performance of web apps and APIs. It lets you define user behavior in code, monitor real-time metrics through a web UI or command. As you can see, a test was performed for system having 50 users and there were 0% failures, meaning the system will behave as expected when it's being used. For the user guide, the user guides provide step-by-step instructions on installing and using the blood bank system. It covers the system requirement, the setting up environment, the running migrations, and creating a super user for admin access. It also shows the troubleshooting tips and to resolve common setup or usage issues. All that is included in the main documentation. For the conclusions, the blood bank system successfully streamlined blood stock management. It automated requests. It integrated predictive analytics. Despite challenges with resources and minimal technical skills, the system has successfully been deployed and met its core objectives. For the recommendations, the system has achieved its goals with positive user feedback, but to enhance performance, me as the developer recommend to integrate more advanced APIs for better data processing and system communication. So this will help the system adapt for future and continue supporting blood bank operations efficiently. So that's the end of my presentation. Any questions? Masi, umepause?
So, can you explain the process of training the machine learning model to how the results are displayed?
Yeah, sure, I can do that. So I'll go here in the training phase. As you can see, the accuracy of the model is displayed here. So what happens during training? .pkl file is created to save the model. Then Flask loads this file and exposes a RESTful API. So when Django sends data to Flask, it uses the model to make predictions and returns the results, which are then displayed on the Django admin dashboard, as we have seen, to help manage stock. Yeah, that's the answer.
I have a question.
Okay.
How is Flask used?
So how Flask is used, it creates a RESTful API that allows Django to send data to the machine learning model for prediction. Then it receives and displays those predictions. Then it helps with the stock management. Yeah, that's it. Any other question or comment?
That was a good presentation.
Thank you.